Hello everyone, my name is Han. Today I'm going to present scalar data field visualization. This work is being done with my supervisor Miguel Nacenta when I was a master's student in University of St. Andrews. Now Miguel is in University of Victoria and I am a PhD student in Paris, France, in University of Paris-Saclay. And so the high takeaway message of this talk is that the hybrid color digit representation could be highly beneficial to visualize scalar data fields when spatial resolution and speed are not the main concern. So scalar data fields are common in both science and engineering domain, and they're usually visualized using color maps, as you can see here, the hydrogen wave function and also the occlusion pressure. But there are several challenges with color. For example, it is difficult to accurately map or perceive the color to a specific value, even you have a good legend. And also, we have spontaneous contrast effect that the surrounding color can bias the perception of that value. For example, here, the inner color is the same between the first row and the second row. However, we perceive them differently because of the surrounding color. And last, it is difficult to hold arbitrary colors just actually in memory if you want to compare two digits, maybe in distance. And there's another alternatives that can address those issues to visualize scalar data field scalar data field. For example, the first one is digits. So this one is just showing the digits in the form of table. It might be difficult for you to have, it doesn't support the overview of the whole field, so you don't see the distribution, for example, but it's a baseline, it doesn't require any data treatment. And the most commonly is used for, it's color map. And in this case, we chose the red and blue color map because it has been recently found to be one of the best in terms of accuracy. And if the media to represent those visualizations is interactive, you can also use a tooltip to reveal the underneath value to the user. And we also can simply overlay the whole digits on top of this color map. And so the digits itself, they are legible, and also the color behind is also visible. And lastly, we have FatFonts. So let's take a closer look at FatFonts. So for FatFonts, the ink used for each digit is proportional to its quantitative value. What I mean is, for example, if you have 9, the ink used for 9 is 9 times the ink used for 1. The ink used for 8 is 8 times ink for 1, and so on and so forth. And to represent the 2 digits number, we use the bigger digit to represent the tens. For example, from left to right, you can read 90, 81, 72, and etc. And with all these alternatives out there, we're seeking to answer the following questions. First, which scalar data field representation work best and for which tasks? And what is the cost of not using visual variables, for example, ink or color? And what is the cost of not using symbolic representation like digits? Lastly, can interactivity provide the benefits of symbolic representation without the drawbacks? To answer those questions, we designed and executed a series of experiments. We recruited 25 participants with various backgrounds. They have self-screened for non-typical color vision. It's within subject design with one independent variable. We have 5 levels, digits, and color, which is the visualization I just showed you before. And we use Microsoft Surface Hub, as we can see from here. And we choose 3 basic tasks. So the first task, locate target value. So in this task, participants were first given the screen like this to say you need to locate the target value, for example, 85. And as soon as she clicked next, she will direct to this page where she's waiting for the visualization behind to be loaded. Once she sees the visualization is loaded, she can get it started. So in this map, in this visualization, she needs to find the target value. As soon as she finds the target value, she just simply need to touch that value, and it will proceed to the next trial. The second task, find extreme value, which is similar to the first one. The only difference is, in this case, you need to find the maximum or minimum value. So you're given the instruction to find the maximum value, and you were waiting for the visualization to be loaded, and you were trying to find the max value here. And after that, you just touch it and you proceed to the next trial. So for the third task, we have cluster. So participant was giving instruction like inside, you need to make a cluster where the inside values are above or equal to 73, for example, and waiting for the visualization to be loaded. And once it's loaded, so you need to find the cluster. And this is example where participant will using the digital pen and to draw a cluster. Once he's finished, he will click the next button on top of that to proceed to the next trial. So we analyze the data using the Bayesian analysis approach and the results. So the first study, the first experiment locate target value. We find that DigitsColor is both fast and accurate. So I can see from the graph here, the first graph shows you the task completion time, second graph shows you the error, and both x-axis show you the different techniques represented by different colors. So in the first graph, task completion time, the lower the better. So the lower the faster it is. And for the error standard deviation, also the lower the better. The lower it's more accurate. So that's the DigitsColor. It's both fast and accurate. And what I also find is that DigitsColor and color are equivalent fast. As you can see from here, this is interesting because it might suggest that overlaying the digits on top of color does not really interfere with the initial search. So it's good news for integrating digits into the color visualization. And second, we find interactive tooltip is slow and equivalent to digits, as we can see from here. And what we observed is that for interactive tooltip, participants spend a relative amount of time scanning the local area trying to locate the target value. And for the digits, they spend another relative amount of time is actually locating the region of interest. And lastly, we show that the error rate for color is pretty large, as you can see from here. And for the second experiment, again, we find that DigitsColor is both fast and accurate. But also, in this case, accuracy of DigitsColor comes at the cost of time. As we can see this task completion time graph here, that color is actually the fastest technique. We also found out that the error standard deviations are doubly higher for finding minimum than maximum. As we can see the graph here, showing the error standard deviation. On the left is showing the minimum, on the right show you the maximum. As you can see here, it is the minimum is doubly higher than maximum. So this supports the previous studies about a nonlinearity in perception, such as Weber's law and Stevens' law. And lastly, for the cluster task, if you only consider speed, and then color will be the best. As we can show here, color is the fastest one among task completion time. However, for the correctness, so the second graph transformed F1 show you the correctness of it's a rate of correctness in this task. And so the lower, the less correct it is. So in this case, the higher, the better. And what we're showing here is that color is pretty error prone. And what I even find out more is that you can gain 10% points improvement in exchange for doubling the time with DigitsColor technique. What I also find is that DigitsColor, digits, and FatFonts are fairly close in speed and accuracy. As we can see here, they're fairly close to each other. However, also for the correctness, however, the DigitsColor has shorter decision time than FatFonts. As we can see here, That's a DigitsColor, and that is FatFonts. So this is interesting way because this might suggest that because FatFonts is using the ink as a visual variable to form the image. So it seems like it doesn't really help that much with a visual overview. And we think it might be because the ink is harder to process for the human's perception system than color. So with those 3 experiments, we answered the previous research question that we found out in all tasks, DigitsColor was both fast and accurate if we discount the fastest technique color. And the second one, what's the cost of not using visual variables? The cost is that it becomes substantially slow, and it depends on different tasks. And the cost of not using symbolic representation is highly error-prone for all tasks compared to the best digit-based technique. And interactive tooltip, well, interactive tooltip was shown that it's much slower than color and less accurate than other digit-based representations. So to recap, the message, the high-level message, the takeaway message I want to show here is hydrate color digital representation could be highly beneficial to visualize scalar data fields when spatial resolution and speed are not the main concern. And with that, I would like to thank you for your attention and encourage to read the paper to find out more.